Bueno, moltes gràcies. Bon dia a tots per invitar-me aquí. Estic molt content d'estar aquí en Catalunya. Hi ha molt bones platges al costat i tal. I que... Hem dit que millor dir Catalunya que els països catalans per no fer problemes. Bueno, okay, I'll give this talk in English. Don't worry. So, I'm Daniel Ehrenberg, or here I tend to say, Daniel Ehrenberg, or if I'm in Germany, I would say Daniel Ehrenberg, just because everybody gets tripped up on the last name. So, yeah, I live about 10 minutes south of here. I work for a company called Igalia. We're a cooperative and we're a consultancy, largely focusing on web technologies. And I work mostly on TC39, the JavaScript Standards Committee. So I'll tell you about that. I hope we're not overlords. I like to think of it more as facilitating with the community to figure out what we all want in JavaScript. Yeah, so the other day I actually walked here to Sitges from my house in Calle Torres Quevedo 22. My town's actually more Spanish-speaking than Catalan-speaking. And so you can just walk through the forest. It's really beautiful. Totally recommend it. So what's TC39? People here used AsyncAwait. AsyncAwait is a new feature of JavaScript that was added in around 2016, 2017. And it was added by TC39, by the JavaScript Standards Committee, which discusses new features and standardizes them. So with AsyncAwait, you can declare a function as async, and you can await a promise. And this is much easier than using the .then method. It's a lot more intuitive for most people, at least for me. So who is TC39? TC39 isn't run like a benevolent dictator for life. Instead, we work by committee. There's this organization called ECMA based in Geneva, where there are various different members of ECMA that are companies and nonprofit organizations and universities. But anyway, those are just in order to get us all at the table together with JavaScript developers, engines like V8 and JavaScript Core, like the things inside web browsers and Node that make JavaScript work. We also have transpilers like Babel and TypeScript involved, frameworks and libraries, people who maintain those, academics of programming languages, unfortunately not Philip Wadler, but we have other interesting programming language people there. And we work on this. This is the JavaScript specification. I don't recommend reading it from start to end. It's about 1,200 pages if you try to print it. I usually just search around. It has really good search features made by Brian Charlson. And that's all developed here on GitHub. The JavaScript specification it's a sort of open source project. We make it on GitHub with pull requests and issues, but we also have meetings. Every 2 months, we meet for 3 days to talk about what sorts of things we should change in JavaScript. We review the activity on GitHub, and we also review proposals and move them through a stage process. So first, at stage 1, we have an idea that we're discussing. And we brought it up in public, and it's on the table. But we haven't decided whether we're doing it yet. At stage 2, we have a really concrete first draft, and we decide as a committee that we're going to go ahead with this idea. But there still may be some more details to work out. At stage 3, we have basically final draft. We've gotten a bunch of reviews, a bunch of buy-in. Hopefully by now it's been tested. People have tried it out in transpilers or polyfills. And we decide, yeah, we're really doing this. It's ready to go. After stage 3, sometimes this ends up shipping in web browsers or in Node or in TypeScript by default, some cases. And at stage 4, there are 2 implementations, and we have conformance tests, and we're ready to say it's part of the standard. So once something's at stage 4, we merge the PR, and that's that. So what's new in TC39? I want to talk about a few features that are coming up. We have Bigint at stage 4. So you know numbers in JavaScript. You might think number, okay, great, I can use this to calculate anything. But actually, it's a floating point number. This is IEEE 754 double precision floating point. So what that means is that when you have a number that's too big, you see rounding artifacts. It's only a 64-bit number. But actually, it's only a 53-bit number because there's also some reserved for the exponent and the sign. So if you add 1 to this, you get the same number back. But with the new Bigint feature, you can use a Bigint by putting n at the end of the number, and then it actually adds 1 properly. But when you use Bigints, you have to use Bigints everywhere, even if it's a small number. And n stands for Bigint, so there you go. We also have optional chaining and nullish coalescing. So optional chaining makes it so that when you're trying to get a property of something, you can do it in a way that works even if it's undefined or null. So if you have undefined or null in JavaScript and you do dot something, you get a type error, which might not be what you want. So people have to construct, you could use double and or ternary operator or conditionals, and this just comes up all the time and makes the code a bit more messy. So with this, you can use question mark dot instead of all those conditionals to say, well, if it's null or undefined, then just return undefined. So you might be using IDX or one of those other libraries. This does or low-get, and this makes it so that you don't have to use that, and you can just use this question mark. And nullish coalescing works really well together with optional chaining. Nullish, this question mark lets you basically set a default. So you have an expression, and then if that's null or undefined, it uses the other one. So you might use double bar. Some people like to use or for this, but this causes a ton of bugs. And it causes bugs because when you have 0 or false, those get treated as falsy by the or. So I hope that this helps people avoid bugs. So yeah, I wanted to mention this stage 4 feature of Bigint. It's already shipping in Chrome and Firefox and Node. These and stage 4 sort of reflects that. These 2 features are implemented, and they should be shipping soon in at least Chrome, and I hope soon Safari. You can also use them through Babel. And the TypeScript people have been really instrumental in pushing forward optional chaining and nullish coalescing because they see this as it's really frequently requested on their bug tracker, and they're involved in TC39 and helping move things forward. We also have Temporal. So who likes date in JavaScript? I'm seeing some hands. I don't know why. Anyway, date is pretty broken, and what we're working on in TC39 is a new date. Who likes to use moment? Or I see more hands than people who raised their hands before for liking date. So the hope is that Temporal is kind of like moment, but built in, and also designed in a way that avoids certain kinds of bugs that people run into. So what we're doing is we have a set of different date types, and you choose the date type based on what data you have. So there's sort of a family of classes. If you have a time, but you don't have a time zone or a day, if you just make that up and set them all to 0 or UTC, this can cause bugs. So instead, you choose a type based on what data you have. And this is at stage 2. We've decided that we want to add this feature to JavaScript, but we're still working out the details. Really soon, we'll be publishing a polyfill of this that people can use if you want to try out Temporal in your applications. And we're looking forward to getting this feedback from the polyfill before standardizing it. Finally, I want to talk about records and tuples. This is a new way to have immutable data. If anybody uses immutable.js or Immer, the idea is that this will be a way that that you can have an object or an array or something that serves that purpose, but you don't have to worry about something else in your code changing it from under your feet. And this can allow for cheap comparisons or potentially cheap sharing across threads and comparison by the contents. So this is stage 0, meaning that it's not even an idea on the table yet. It's something that we're discussing, we're thinking about putting it up at a future TC39 meeting. Anyway, this talk really focuses on class features. So I wanted to talk about decorators, but this is in the context of ES6 classes where we're adding other features in addition. So I want to start by talking about those other class features, in particular private fields and methods. So web components. This isn't a talk about web components, but the example is with web components. So a lot of people don't like web components, but they're not really essential to this example. So here you have a counter that subclasses HTML element. What it does is when you click on it, it increments a number, and it does this by setting this text content. And so in the constructor, which gets called when you do new counter, or it also gets called when you have a num counter element. It gets called sort of implicitly by the system. In the constructor, there's this dot underscore x equals 0. And the first thing that we're adding, which you might already be using in Babel or TypeScript, is the ability to declare fields. So instead of putting it in the constructor, you can put it in the top level of the class, where you say, this field name equals this value. The second thing we're doing is adding private hash. The hash sign is a bit controversial, but it's what we've settled on. You use the hash as the first character of the name that comes before both the definition and the usage. So instead of having underscore x, we have hash x. Hash is the new underscore for when you want strong encapsulation. In particular, if you have underscore, a lot of people use underscore as a convention to avoid to just signal through how they're communicating with other programmers that this shouldn't be accessed outside the class. But you actually still can access it outside the class. With hash, you cannot. Actually, even with TypeScript private, you can declare something private, and TypeScript will yell at you for using it. But you can just use various tricks to just tell TypeScript to go away and access it anyway. And this causes real problems for library developers and framework developers. This has come up in Node Core, in Moment, and lots of different programs where an API is designed, there's some internal data that's held in an underscore variable. People use it because they find something that they want, but then it's not possible to evolve that library anymore. So it's not possible for the library maintainer to change things. And something that wasn't designed to be part of the public API is part of the public API. I think these library authors should have the ability to have control and determine what these are, what their interface is, because ultimately we really benefit from these library authors being able to evolve their code over time. They can make things more efficient by changing the internal representations without breaking anybody's code. That's the hope. So this proposal for private is at stage 3, and it's partially implemented and shipping in V8. You can use it in Babel and TypeScript, or at least TypeScript is planned to be released soon, but you can use it in Babel today, and hope it works well for you. So I want to talk about decorators, which sort of build on top of all of this. What are decorators? So we have our class. The goal of decorators is to avoid repeated code and sort of extract away some shared parts of the structure. So, for example, every time we change that x, we have to call this render method. But what if we could just mark that as observed? And what if instead of defining the custom element at the bottom, we could define it at the top? That would be more intuitive. Or even for methods, if we could declare a method as bound instead of having to call bind every time we use it. So decorators let us do these kinds of things. They also help frameworks move towards classes. So here's an example from Ember, from their documentation, where they have this component.extend API, and it takes a big object that has a bunch of stuff in it. They can't use classes for this because they have these features that classes don't have, like this computed. But with decorators, we can declare these as parts of the class. So this really helps make things more composable and helps the code be more understandable. This way, type systems can understand the code because they understand what a class is. If you just have this object, there's not much for the type system to latch onto. It's also, hopefully, more composable, that you can do things, you can do everything in this class. You can use other decorators that weren't even designed by the Ember team instead of having to put everything in this framework-specific way. So these decorators, like people raised their hands earlier, they're pretty popular. People are using them in all sorts of different frameworks and outside of frameworks, maybe for logging. So it seems like we've had this general sentiment that decorators are heavily used, and so they should be standardized. And this is reflected in TC39 also. By being at stage 2, we've decided, yes, we want to standardize decorators. Some of the use cases are like the ones that we talked about with decorating fields and methods and whole classes, but there's other features that were sort of added later as the proposal evolved. And there are other features that people have been writing in on the issue tracker, because we're all on GitHub. We'd really encourage feedback on the GitHub issue tracker to talk about other things that could be decorated. So we're starting off here with decorators for classes, but my hope is that in the future we could allow decorating more things. So it's important that decorators be efficiently implementable. The original version of decorators generated code that slotted really well into the output for a transpiler. The output for something like Babel or TypeScript, it's just when it compiles a class into what we call ES5, like the previous versions of JavaScript, you just have this extra line that you insert, which is run the decorator before you finish constructing the class. But there are some challenges in implementing the new version of decorators, either natively in transpilers or in JavaScript engines, that I'll get into a bit more. And decorators should be easy to use. It should be easy to write, to use someone else's decorator, and maybe secondarily, it should be easy to write your own decorator. But I think most programmers will be using decorators that they get from a shared library. So, history of decorators. Decorators have been around for a long time, around 2014, 2015, in a collaboration between Ember and Angular and TypeScript and Babel and many other ecosystem actors. We had this original decorators that you may be using. You have to say, I want Babel legacy decorators or TypeScript experimental decorators in your configuration files. And what these are is basically it's a function. So we have this @enumerable decorator there, and what that does is it gets called as a function whenever the class executes. So in some programming languages, classes are simply declared the system sees them. In JavaScript, it runs from beginning to end. And when a class declaration is hit, there's some code that executes that sets up the class. And decorators are some code that executes inside of this class execution. And they get called with, in this case, 3 arguments. The target, which is greeter.prototype, the object that has all the methods on it for the class. The property key, which will be greet, and the property descriptor. So what's a property descriptor? Property descriptors are the thing that you put in object.defined property, or are there other similar APIs? It's a little object that represents things about the property. So you have the value, writable, there's other properties of it like enumerable. And so you have the property key, which is the second argument there, your property 1. This is a page from MDN. And so this decorator proposal is based on property descriptors. It's based on when the class is being defined, before creating this property descriptor, it would run this decorator. And what that does is this decorator changes the property descriptor, and then it applies. As decorators were evolved over time, the proposal from Yehuda Katz and Ron Buckton and Brian Turlson evolved into having more elaborate descriptors that would provide some more capabilities. And when I got involved in this proposal a bit after that, I added even more capabilities to interact better with private and with field declarations. And actually somebody in, a contributor in Madrid wrote up this convenient table to describe all the properties. So I found this table to be really clarifying, but a lot of people are kind of scared, like, wow, it's a big table. Anyway, the descriptor-based decorators, the original version, based on property descriptors, didn't end up being sufficient because of several different issues. One is about how fields work. We decided that fields in JavaScript classes should be based on define rather than set. What we mean by that is it's based on using object.defined property whenever you have a field on a class, rather than based on just this.x equals the value. And that means that we don't actually call the setters. If you do this.x equals value, it's going to call any setter that's installed by the superclass or on the prototype. And with object.defined property, it just overwrites all those setters and puts on a value property. But this doesn't work with some of the techniques that people were using for certain kinds of decorators, including some of them in Angular decorators. There's also the issue of how to integrate with private. We don't have property keys for private. It's unclear how these things can be extended over time. When you have a simple function, it's called with certain arguments, and it's not we can't just change that because it would risk compatibility. Whenever we're changing JavaScript or something on the web, a key thing to think about is this slogan, don't break the web. The web has, and not just the web, but also the broader ecosystem like node modules, they use JavaScript in all these different ways. And if you make a change to how existing programs run, you break them. So I think the strength of the ecosystem is really the big set of working code and libraries that we have. And so we try to evolve that in a way that doesn't break those. One of the big pain points for decorators today is that TypeScript and Babel have some slight differences in how decorators work. So the current state of the ecosystem of just with transpilers and with the semantics that Babel and TypeScript have is not really a comfortable place. So we do want to push forward in terms of standardizing this at TC39 so that we can bring unity to the ecosystem while also addressing these other problems. But there are further problems with decorators. There's language level issues. So I mentioned object.defined property. That's not the easiest thing for everyone to understand. And with the stage 2 decorator proposal that evolved later with that bigger table, there's even more to understand. Yeah, some details about the evolution over time. But the biggest cause for concern from implementations was that these would be slow. The concern was that the decorator proposal would slow things down. Actually, Niccolò Ribaldo implemented these complex descriptor decorators in Babel, and LinkedIn tried those out and found that it slowed down their website, which is pretty unfortunate. There's a lot of code generated to create and process these descriptors, and it really wasn't clear how tooling should make those decorators go faster. But actually, the same problem exists in JITs. I think many people were predicting, well, with a JIT, things should just become fast. Or then the JIT people were predicting, on the other hand, okay, well, I don't know. In a JIT, it's going to be hard to make it fast, but the tooling should be able to make it fast. With JavaScript engines, you think, okay, it has a JIT, you should be able to make anything fast. But that's not really how it works in practice, because you have to, there's the interpreter that runs. So these days, a lot of people are thinking about load performance. Who here is thinking about how to make their page load with decent performance? Wow, that's large, maybe more than half the audience. So the big concern was that if you use decorators, then it's going to make your page take longer to load. And I think it's important as a design goal that not be the case. The decorators don't slow down your program. But the way that JITs work is first they have an interpreter that runs over your program. And then if something runs a lot of times, it can run through this compiler. So JIT is a just-in-time compiler, and it only runs on parts of the code. So the problem is at startup time, you're incurring a lot of execution of the interpreter. Maybe you can cache the compiled code, but anyway, when you go to the web page the first time, if you get a new customer, you don't want that person to have a slow experience. So ultimately, the processes that generate bytecode are sort of like a static compiler. They're sort of like what transpilers have, because they only get a little bit of time to analyze the code before they have to execute it. If they spend a long time thinking about it, well, they've already lost. So for implementations, it's nice if it's easier to see what's going on with decorators. And the thing is that the use of decorators actually does tend to have a fixed shape. So the proposal that we're looking at in TC39 to sort of square the circle is to make decorators more statically analyzable. And the idea here is having built-in decorators and composition. So we have some core building blocks, which are the built-in decorators, and there's the ability to define new decorators in JavaScript based on composing these. These decorators are wrap, register, expose, and initialize. This is sort of the initial proposal. And you could define new decorators by putting those together. So I want to walk through a couple examples. At register lets you schedule a callback that gets run at a certain time. So I mentioned this define element. So we import this decorator from a module, and we call define element on the class. What we want this to turn into is that then you have the class and you declare it. So you could think of these decorators. Decorators are usually sort of like macros. They're transforming the code in some way. So what this register does in general is you pass it a function, and it calls that function on the class after the class runs. And you could use it directly. So we could pass in this arrow function, and what that'll do basically is get that function called on the class. And so going back to the initial example, we could define that by exporting a decorator which calls at register with this new syntax for declaring a decorator. And it takes this argument name and it passes that name in. Similarly, for wrap lets you sort of pass something through something. So if you have a method, you can wrap it in another function, for example, to allow logging. So if you want to see every time a particular method is called, what this basically does is insert an extra console log statement at the beginning of the method. So what wrap does is, it's basically like you define the class, and then you change the class by calling that function. So you can use this directly. You can have a class where you have this @wrap, and over the method with this big arrow function that wraps this function in something that logs and then calls the underlying function. And basically that makes it so that you have this log there. It modifies the class afterwards. And you can extract this away into a library. So I think it's very important that people be able to define their own decorators. I think that this is how people are using decorators now. If we asked everybody who's running code to change it to explicitly use wrap, that would be more ugly and sort of not a good abstraction. So for next steps, I'm recommending that people don't upgrade to these decorators yet, or don't upgrade to any of the other proposals that were made yet, and just for now stick with using these legacy or experimental decorators. These have been used for years. They're well supported by tools, and they're the best option we have at this point. A goal of this proposal is going to be that for people who use decorators, there's an automated way to upgrade to the new version. You can see in these examples that it's not quite the same. When you import a decorator, you import it with the @sign. That's so that these decorators can be more statically analyzable. They're not first-class JavaScript values. They're you could call them second-class. They're only things that are declared this way with this decorator declaration. But the thing about it is that you could have a code mod that adds the @sign in the appropriate place. There are some other small changes that would happen as well. Though for people who write decorator libraries, there will be some changes. So yeah, we've been staying in touch with many people who have decorator libraries and making sure that their use cases are met. The other thing is that we're still developing consensus about this proposal. So TC39 is a committee where we discuss things and we try to build consensus. We try to all agree on something. And this proposal is not yet at the stage where we have consensus on this particular static decorator path. I've gotten some positive feedback and some negative feedback, and so we're going to have to talk this over and come to a common conclusion before we can standardize and conclude on a result. Anyway, from here, working with things like Babel are really going to be essential before standardizing this proposal. So many things get prototyped there, and we can try them out and get feedback. In this case, an implementation is in progress, and the idea would be to release it to everyone before we actually promote this to stage 3. Because when we promote it to stage 3, that will indicate this stability and sort of semi-finality. So I really regret that decorators are taking this long, and I hope we're in the sort of final stretches of it. And you can get involved and help with decorators as well. So we have a discourse instance. We're happy to discuss ideas there, as well as GitHub repositories. If you go to github.com/tc39/proposal decorators, you can file issues and say what you think about the proposal. You can also find a more detailed README that describes it in a bit more detail. In TC39, we have a conformance test suite. So we have tests that run in all the different JavaScript implementations. It's called Test262. It's an open source project that is really positive for contributors. And there's a lot of different areas of JavaScript that could be tested. So if you want to get involved, there's no need to use C++. These tests are all written in JavaScript with some Python test infrastructure. Also tooling or various different JavaScript engines. Could be Babel, could be JavaScript engines in browsers. These are all open source projects these days, or basically all. And it's great to get started in these in bug fixing, or could be in feature development, though sometimes those get snapped up pretty quickly. And Babel is open to implementations for newer features, so that can be a way to get started. And once we do have these draft implementations, prototype them in your code base. So I don't really recommend using all the super newest features in these super critical production code, but there's a fine line. There's a lot of different ways that people can do things. For optional chaining, for example, that was put in the Facebook and like React presets a while ago when the proposal was still at stage 1. And in the end, the proposal didn't actually change before it got to where it is now at stage 3, and it seems to be shipping very soon. However, decorators took a sort of different path, where those were very widely made available, and now they do seem to be changing a lot. So it's all about sort of your appetite for either potentially relying on older tooling or potentially changing your code later if the feature ends up changing. But feedback from prototyping is extremely useful. And so if you do try out a feature, then please write in on Discourse or GitHub and tell us how it went. We could also use help writing documentation. For example, MDN, the Mozilla documentation site, could use a lot of help with localization. So MDN has really great reference documentation for JavaScript and the web. But in Spanish and Catalan and other European languages, there aren't always translations. So even if the programming world is somewhat run in English, it really helps people learning to not have to both think about foreign language and think about the programming. So we also need help with particular new features that to get this documentation. We also work on more sort of introductory educational materials, and a lot of this is coordinated through the GitHub repositories for the features. So that's a good place to start if you want to get involved. You can also join ECMA and attend TC39 meetings. But I also want to say that we should take it easy about these things. Some people have this feeling that you have to be on top of all the new technological developments, and if something is being developed in TC39, everybody has to be sort of understanding it. People get overwhelmed and they say TC39 is doing too many things because I can't understand all of them. And first of all, we haven't decided that we're doing things until they're at stage 2. There's a lot of different proposals at stage 0 and stage 1. But also, not everybody has to know everything. This is a very broad ecosystem. Sometimes we take complexity into the language and remove complexity from other parts of the ecosystem. So yeah, anyway, no need to follow all this stuff to be a good developer. We all focus on different things, and in general, if you do contribute, and I really do encourage contributions to TC39, it's important to have balance, not go too overboard, as I've sometimes done. So in conclusion, yeah, decorators are making progress. I hope that soon they'll be at a more stable point, and I regret that they're not there yet after so many years. And you can help TC39 move JavaScript forward, not just for decorators, but for all sorts of features that we're developing. And yep, thank you.